Hi, I'm Camila,
I'm Jray.
and we are doing our presentation on night and day and how it reflects on the sinusoidal
Yes, period 4.
precalculus. What is our equation and why? So our equation is on the bottom half of the presentation, and it shows 6 different sinusoidals based off of like the different tropics and the equator. The reason our most important part of our function is the amplitude. The amplitude shows why we have longer days and shorter days. The sinusoidal with the more like curves are the ones with the longer days, which represent the longer days. 4.9 sine 2 pi over 24, which shows how these longer days have kind of more daylight than the shorter days. And then the shorter day sign would be one sine 2 pi over 24, and these are more condensed because there's less daylight. And the reason the amplitude changes because of the tilt within the axis um, on the Earth, and how the Earth also orbits the sun, leading to different seasons and different longer and shorter days throughout the year.
The Tropic of Cancer and Capricorn. The Tropic of Cancer and Capricorn play a significant role in our seasons as based on the 23.5 degree of the Earth. The Tropic of Cancer is 23.5 degrees north of our equator, making when the sun hits it, that is when we experience our summers. And we have our Tropic of Capricorn, which is 23.5 degrees south of our equator. And when the sun approaches our Tropic of Capricorn, that is when we experience our winters. Okay, the sun. The length of daylight and darkness on Earth varies throughout the year due to the Earth's axial tilt and its orbit around the sun. During the summer solstice, the hemisphere tilted towards the sun experiences longer days and shorter nights, while the opposite hemisphere experiences shorter days and longer nights.
Um, why do we have seasons? We have seasons because the Earth is tilted to 23.5 on its axis, which changes how the sunlight reaches each hemisphere as Earth orbits the sun. When your hemisphere is tilted towards the sun takes a longer path across the sky, resulting in longer daylight hours. Mathematically, this is related to the solar declination angle, which shifts throughout the year and affects how long the sun is above the hemisphere. When your hemisphere is tilted away from the sun's path is shorter, leading to shorter days. Lastly, we have some graphs that show how the sinusoidal would look on the Earth. December and June are the shorter days, and how basically there's less sunlight during like 11:30 p.m. On all of these, and then September and March are the longer daylight days, and these all of 4 of these are basically the extremes out of the year and show how the like really short days versus the very long days and how they compare to each other. And we can see on September and March they more look like cosine waves because there's more sunlight, while in December and June they're shorter and they look more like sinusoidal waves. Okay, thank you for listening to our presentation.
Thank you.